Hi there, class. Mr. Pusky here. Hope you're having a good day so far. So this is a video for 1.1 in Advanced Math Topics. Chapter 1 in this class is going to be a review of Algebra 1 Foundational Skills. And so this first lesson is just kind of, a lot of the chapters kind of a review, and I kind of want to gauge, I guess, what you remember from Algebra 1 or other classes, and that's good to kind of warm up our brains and make sure we know what we're doing. And so I'm going to ask you kind of to try these first to kind of refresh your memories. It's good to kind of try problems before we kind of go through them, because I don't want to tell you things you already know, and so it's good to kind of like process things before we go through them together, okay? All right, so we have a warm-up here. Well, the central question is, what concepts from Algebra 1 and geometry do we need to practice? Our warm-up is, this will be more in class, but brainstorm with students around you what topics you remember from previous math classes, such as distribution, factoring, simplifying expressions, etc. Go ahead and create a list. All right, so obviously I won't be able to see what your list was or have you share it with me, but yeah, it's good to kind of think about what we covered in other classes that you might need to think about. And then, like, now that we've kind of created a list, what topics do you think you need to practice more this semester? If you want to look at in this lesson and kind of see, what you remember or what you need help with, go ahead and take a look. All right, sounds good. We're going to jump down here now. So now, would be kind of a good idea for these sections is to, I guess, kind of try them. We'll kind of, we have different sections. I would like you to maybe try a couple and then kind of rate your understanding level from 1 to 5. So 1 means I need a lot of help, and 5 means I totally understand. So we have integer operations. It says evaluate the expressions, and so basically it's asking you to add or multiply or divide these, or subtract, I guess. And so why don't you guys go ahead and try a few of these and see what you remember and give yourself a rating. All right, sounds good. So a couple things here. When we are adding fractions with same signs, so if we have, I guess I need to write here. If we have a positive and a positive, or a negative and a negative, when we add them, I guess it's the same sign, right? Same sign. We are going to, in our brain, we're going to add, let me see here, and keep the sign. Okay, we're going to add and keep the sign. If we have different signs, we do something like, if we had, for example, we had a positive and a negative, we're going to subtract and keep the sign of the bigger number, in quotes. Not necessarily bigger, like more positive, but bigger in terms of, like, for example, like -5. Like if you have -5 and 2 obviously bigger because it's more positive. But what I mean by that is that 5 is the bigger number than 2, so that's technically the bigger number in this case. Okay, so let's go through this here. So we have -5 plus 2. Are those same signs or different signs that we're adding? They're different. So we're going to subtract these. We're going to do 5 minus 2, which equals what? It equals 3. And then which number is bigger, 5 or 2? 5 is bigger, so we're going to keep the sign of the bigger number. So what we're going to actually do, I guess we'll go down here. It's because 5 is bigger. It's going to be more negative than 2 is positive. So our final answer is actually going to be -3. Okay? So you in our brain, when they're different signs, we subtract them, bigger minus smaller, and we keep the sign of the bigger number. Okay? All right, number two, so when we subtract, what we like to do with subtraction is we like to add the opposites, or we do what's called chop, or chop slash. Okay, I don't know if you've heard either of those before, but adding the opposite, basically you're going to, or change the sign, add a line is another thing that people say. So what you're going to do is you're going to chop. If there are two negative signs, you're going to do chop, make them both positive. And now we have 7 plus 6, which equals what? It's going to be 13. Okay? Well, if we had different signs, what if we had, like, I guess -13 minus 6, right? Well, in this case, what we're going to do is we're going to do chop slash. We're going to change the sign, add a line. So we have -13 plus -6, okay? Now we're kind of back to what we were doing on the left-hand side over here. We're adding up. These have the same sign, so what we're going to do is we're going to add them up. So it's 13 plus 6. 13 plus 6 equals 19, and then the sign is negative, so it's going to become more negative. It's going to be negative 19. It's going to be your answer for this one. So for this one, we do chop, chop. We do chop, chop if they're both negatives. We do chop, slash if it's plus a negative. But hopefully at a certain point, you'll get pretty good at doing this in your head. But yeah, that's kind of how I do it. So it's good to change it to addition if you're struggling with this, but chop, chop, and chop, slash is a good way to kind of make it a little bit more manageable here. Two negatives make a positive when you're doing that, okay? Make sure you put a rating. Think about how you're feeling with. Actually, we got to do 2 more problems here. So, all right, next thing we have here, a little bit different, but we have -3 times -4. So 2 negatives when we multiply equals a what? Kind of weird here. This is going to be a positive. It's going to be positive 12. Okay. So so again, kind of same sign equals a positive, and then different signs equals a negative. Okay. When you're multiplying, that also applies to dividing. Okay. So we have -3 times -4 are both negative, becomes 12. And then we have different signs. If you had, for example, if you had 20 times -3, that'd be -60 because it's positive and negative, okay? And I guess a good example, what I like to say with this kind of problem is that when you, so if you have the same sign, if you have 2 positive people in the same room, they're going to be kind of positive and happy and talk about unicorns and rainbows, and they're going to have a wonderful time. But if you have 2 negative people in the same room, they're going to have a good time because they're going to complain about everything and be negative together. But if you have a positive and a negative person together like this, you're going to have a negative time because they're going to get on each other's nerves, okay? All right, how about this one over here? We got -20 over 5. What's that going to equal? That's going to equal, we have, so 20 divided by 5 is 4. Is it going to be positive or negative? It's going to be negative because positive or negative and a positive is going to make a negative, okay? All right, next section here, we have order of operations. Why don't you guys go ahead and try and see if you can solve these, and then make sure you give yourself a rating for how comfortable. 1 means really struggling, 5 means doing great. Okay, so order of operations, it's going to be PEMDAS. Okay, let's actually review PEMDAS here. So PEMDAS stands for, let's go over here actually. P is what? Parentheses. Okay, E is exponents. See if you can fill out the rest of it if you're able to. M is multiplication. D is division. A is addition. And S is subtraction. Okay. So what we need to be careful about though is with a couple things we need to know. With multiplication, division, and addition, subtraction, we need to work what to what? It's going to be left to right for both of these. Left to right. Okay? So we got to work left to right. So even if you had, like, for example, if you had 10 minus 2 plus 4, because these are equal ranks, subtraction and addition, even though they're kind of, addition comes first in PEMDAS in the acronym, you have to go left to right. So what comes first, left to right here? Well, we got 10 minus 2 is going to be 8, and what's 8 plus 4? It's going to be 12. So it's not 10 minus 6, it's 8 plus 4, which is 12. We got different answers there, okay? All right, let's do these here. So now we know that, so then in your parentheses a number 1. Yeah, we got -4 plus 1. What's -4 plus 1 going to be? -4 plus 1 is going to be what? -3. Subtract them and keep the sign of the bigger number, right? All right, very cool. Any other parentheses? No. Any exponents? No. Any multiplication or division? Yeah, we got multiplication. Actually, we got division here. So we're going to do this part right here. So we got -6. What's -15 divided by -3? So it's going to be 5. It's going to be positive or negative? Well, 2 negatives are going to add to a, they're going to, become positive. So we got +5 minus 2. Make sure I check my notes here. All right, where are you? Okay. All right, and then what's next? No other multiplication or division, any addition or subtraction? There is. So we do -6 plus 5 or 5 minus 2? We got to do -6 plus 5. We got to go left to right, okay? What's -6 plus 5? Well, different signs, we're going to subtract. 6 minus 5 is 1. 6 is bigger, so we're going to have -1 minus 2. And then -1 minus 2, so we could do chop slash if we wanted to. That helps you. If that -1 is going to get two more negatives, which is going to be what? It's going to be negative 3. Very cool. Nice. All right, how about number 2? Any parentheses here? Yes, we got 6 minus 4, so let's do that. What's you always do PEMDAS, you always start at the beginning every time to kind of make sure you got all the things that kind of go together here. And I like to go step by step to show my work to make sure I didn't miss anything, okay? What's 6 minus 4? 2. And when there's a single number in the parentheses anymore, you don't really need the parentheses, so that's good to know. So my times negative 10 divided by negative 2. All right. Any other parentheses? No. Any exponents? No. Any multiplication or division? There are. I see multiplication and division, so how do we know where do we go? Where do we start? Well, we got to go left to right. So if we go left to right, even though like multiplication technically comes first in PEMDAS, we're actually going to divide first because they're equal rank. They're like both captains, okay? So what's 10 divided by 2 going to be? 5. So we got 5 times negative 10. So we did this. So I got 5 times negative 10 divided by negative 2. Still go left to right here again. Got multiplication division. Left to right again, we got 5 times negative 10 is going to be negative 50 divided by positive 2. And what? Oh, it's actually negative 2. My bad. And what's negative 50 divided by negative 2? It's going to be positive 25. All right, very good. Cool. Make sure you give yourself a rating there. Just kind of gauge what you want to review in this chapter. All right, fractions, operations with fractions. Fractions are tough for a lot of people, even up in through Algebra 2. So why don't you guys go ahead and solve these, see if you can remember what we're doing here, and we'll go through them together, okay? All right, with fractions, I have a fraction wrap I like to do. I guess I'll do it here just because it helps me, and hopefully it'll help you. So it's multiplying fractions, no big problem. Top times top over bottom times bottom. Dividing fractions, easy as pie. Flip the second and multiply. When adding up or taking away fractions, don't be a hater. Bottom numbers have to be the same common denominator. Okay, so a lot of people I see with fractions, and you're welcome. That was wonderful, I'm guessing. Hopefully you can put that on SoundCloud. But anyways, so I see people are like, when do we find a common denominator? When do we like cross multiply? I see a lot of people like kind of do this thing. If we have 1/2 times this, when do we cross multiply? We're actually going to cross multiply when you have a equal sign in the middle. Okay, so that's good to know. That's only for like proportions. Okay, so in this case we have 2/5 times 3 over 8. Well, it's multiplying fractions, no big problem. Top times top or bottom times bottom. Okay, so let's go ahead and do this a couple ways here. So top times top, what's 2 times 3 going to be? It's going to be 6 over, what's 5 times 8? That's 40. Okay, now we got to reduce this, which is kind of tough. We have to find the biggest number that goes into 6 and 40. So if it helps you, you can list the factors of 6. We got 1, 2, 3, and 6. So what's the biggest number of these that go into 40 as well? Probably going to be 2, right? So 2 goes into 6 how many times? 3. 2 goes into 40 how many times? 20. So we should get for an answer 3 over 20. Okay. Now I'm going to show you a different way to do this one, okay? Because when we're multiplying, we can kind of make our lives a little bit easier. Because if you get some big numbers at the end, you're going to be in kind of trouble here, which is not all that great. What you can do before you reduce over here and multiply is you can actually reduce before you even multiply. So we can reduce vertically and diagonally, okay? Which means you can like do the cancellation thing like vertically or diagonally. So let's go ahead and check that. So we have 2 over 5, a number going to 2 and 5? No. How about 3 and 8? Also no. How about 2 and 8? Yeah, so what number goes into 2 and 8 nicely? Well, 2 goes into 2 once, 2 goes into 8 how many times? 4 times, okay? How about 3 and 5, anything? No, those are both prime numbers. So now we have nicer numbers here. We have 1 over 5 times 3 over 4, right? Now if we multiply that, isn't that a little bit nicer? What's 1 times 3 on top going to be? It's going to be 3. How about 5 times 4? 20. So see, we got the same answer here. So it depends there's lots of ways to approach this here, but I kind of like to cancel first, but not always. It really depends. It's kind of, once we get more fluent, we'll see what we like, okay? How about number 2? We got 9/4 divided by 5 over 2. So it's dividing fractions easy as pie, flip the second and multiply, or some of you probably have heard of something called keep, change, flip. So it's basically what we're going to do is we're going to keep the first one, we're going to change it to multiplication, and we're going to flip it. And then we're just going to do multiplication again, okay? Or dividing fractions easy as pie, flip the second one, which is this one, and multiply. It's kind of what we did here, okay? Why don't you guys go ahead and try what we just did on the last problem here and see if you can either reduce and multiply or multiply across and reduce. See how you do. All right, so I'm going to go ahead. Let's multiply across first. Let's do it both ways here. What's 9 times 2? 18. How about 4 times 5? 20. What number goes into 18 and 20 nicely? I think it is going to be, I guess we'll try 2. Let's try 2. So 2 goes into 18 9 times, 2 goes into 20 10 times. So we get 9 over 10. So that's one way to do it. Or we can go over here and we can reduce first, right? So can we reduce vertically anywhere? Oops, that's a 5, my bad. Can we reduce 9 and 4? No. How about 2 and 5? No. How about 9 and 5? No. How about 2 and 4? Yeah, what number goes into 2 and 4? 2. 2 goes into 2 how many times? Once. 2 goes into 4 how many times? 2. So now we can multiply across. We got, so now we have 9 over 2 times 1 over 5, right? What's 9 times 1? 9. What's 2 times 5? 10. So we got the same answer 2 different ways. All right, so that's how you multiply and divide. Now we're going to be doing adding and subtracting. So with this, we need a common denominator, okay? So we need a common denominator. You guys remember how to find that? Find a common denominator. Like the easiest way would be to multiply just by the opposite denominator, kind of like multiplied by each of these, the 3 and the 4. Or you can kind of like list like multiples, the least common multiples. So you can go 3, 6, 9, 12, 15. You can do 4, 8, 12. Okay, and you can kind of see that like in 16, you want to find the smallest number that divides by both numbers, right? And so for this case, it's 12. But whatever way you're comfortable with doing that, it's kind of up to you. So we're going to multiply it to get a common denominator, top and bottom on both sides. So 3 times what is going to be 12? It's going to be 4. How about 1? 1 times what? Are we going to do top and bottom by 4? How about over here? 4 times what's going to be 12? So we got 3 and 3. All right, let's do that. 3. So we multiply it. So 4 times 1 is going to be 4. 4 times 3 is going to be 12. Plus, what's 3 times 3? 9 over 4 times 3 is 12. And then we just kind of go ahead and we multiply. Now what do we do? Do we actually add both, or just the top, or just the bottom? What do we do? Yeah, well, if you have like, I guess 1/4 of a pizza plus 2/4 of a pizza, you'd have 3/4 of a pizza, right? It wouldn't become like 3/8 of a pizza, right? So we're going to go ahead and add these. We get 13 over 12. We keep the denominator the same. We add up to the top and keep the denominator the same, okay? How about number 4? Similar thing. Adding and subtracting, we need a common denominator. So what's the common denominator between 5 and 10? What do you think? Well, we don't always have to multiply both. We can sometimes multiply 1. So actually the common denominator between 5 and 10 would be 10, right? So we can actually keep this one the same over here. What's 5 times what is 10? 2. So we have 2 times 8 is going to be 16 over 10 minus 13 over 10. And we get 16 minus 13 is going to be 3. So we get 3 over 10. Nice. There we go. Okay, make sure you give yourself a rating here. Fractions are tough, even up through Algebra 2 and even beyond. It's a really tough thing, so make sure you guys are honest with yourself about this, okay? How about distribution in like terms? Why don't you guys see if you remember about this, and then we'll go through some examples. All right, so distribution is multiplication, okay? We're multiplying things. So this is kind of the rainbow method or the loop method, okay? We're going to multiply everything in the parentheses by everything in the other, everything outside the parentheses by everything inside the parentheses for this first one here. So let's try this here. So let's go ahead and do -3 times this. What's -3 times 2x squared going to be? Well, that's going to be -6x squared, okay? Then we got -3 times -5x, which is what? -3 times -5 is positive 15. We got an x. Then we got -3 times positive 4 is going to be -12. All right, now we have to combine like terms if we're able to. Are there any like terms here? Well, like terms, okay, see if you can remember what the definition is. Like terms are going to be the same variable and the same exponent, okay? So for example, we have x and x here, but this one is an x squared, so that's actually the X squared is different than the x. So actually, this is going to be our final answer here. We cannot combine like terms because they're not all the same variable, same exponent. Okay? All right, why don't you guys go ahead and see if you need a kind of a refresher there, see if you can try the rest. All right, number 2. So we're going to distribute combine like terms. So we got 2 times 5x in the parentheses here. What's 2 times 5x? 10x. How about 2 times negative 6? Negative 12. Do we multiply the 2 times the negative 3x or no? We actually don't because it's not in the parentheses. So we're actually not going to do it. We're just going to leave the negative 3x here. Okay. Now, what are the like terms here? Well, the like terms are going to be, we got 10x and 3x, and negative 3x. And to combine like terms, we're going to add the numbers in front. The numbers in front are going to be 10 and negative 3. What's 10 minus 3 or 10 plus negative 3? We're going to get 7x, and then this minus 12 is a different term, so we're going to kind of keep it the way it is. 7x minus 12. All right, very cool. Now we're getting even tougher here. We got some double distribution stuff going on here. All right, so for number 3, we're actually doing multiple distribution things happening here. So let's see how this goes. We've got to multiply everything in one by everything in the other. So we got x times 3x is going to be what? It's going to be 3x squared. How about x times negative 7? Negative 7x. How about 4 times 3x? That is 12x. And how about 4 times negative 7? Negative 28. All right, what are the like terms here? Well, I see we have negative 7x and 12x both have same x to the first power, each both to the first power. So we're going to add those, keep the rest the same. So we got 3x squared plus what? 5x minus 28. All right, there we go. All right, and then that last one here is like probably one of the hardest of all, but what I would say for this is you want to start with the smaller terms. So terms of numbers, like how many things have addition, subtraction between them. So this one is a binomial, 2 terms. This one is a trinomial with 3 terms on the right there. So yeah, we're going to use 2 different colors here to kind of keep them separate. So let's go ahead and do 2x times everything first. We got 2x times x squared is going to be what? 2x to the third. We got 2x times 6x is going to be 12x squared. And we have 2x times negative 1 is going to be negative 2x. We use a different color now. Now we got to do 3 times everything in the other parentheses. So we got 3 times x squared is going to be 3x squared. 3 times 6x is going to be 18x. And we got 3 times negative 1 is negative 3. So I got to use like terms here. So we got x to the third. I can start with the biggest exponent first. Then we have x squared here and here. And then we got x and x. And then we got whatever symbols you want to use is fine. Then we got the 3. So biggest exponent is 2x to the third. And if you have a lot of things happening here, I like to cross them off as I go so I know I'm done with it. Then we got 12x squared plus 3x squared. What's 12 plus 3 going to be? It's going to be 15x squared. Okay, remember you do not add the exponents when you add, only when you multiply. Then we got negative 2x plus 18x is going to be what? It's going to be 16x. Then we got minus 3. And that's our answer. All right, very cool. Make sure you give yourself a rating for that. See how you did? Okay, cool. Now we're solving equations, the bread and butter of algebra. See how if you can solve some of these and go ahead and give yourself a rating if you want. Okay, sounds good. So for solving equations, we're doing the opposite of PEMDAS. We're going to be undoing operations that are happening to x, okay? So if it's like if x is like adding 6, you're going to subtract 6 to get it by itself, okay? So let's go ahead and do this here. We have x minus 4 equals 7. And what's the opposite of subtracting 4, which is happening to the x? We're going to add 4 to both sides, okay? I know this is really easy. You can probably guess what the answer is going to be, which is 7 plus 4 is 11. You can probably guess that the answer is 11, but I really need you to show your work and really make sure that we know what we're doing here because, you can guess numbers now, but we're going to get to a point where you can't guess, and they're going to be like, oh, crap, I don't really know how to get x by itself. So make sure we know how to do this way, okay? As long as I think that's probably one of the best things to do, okay? How about number 2? We got x plus 8 equals negative 3. How do we get x by itself? What's the opposite of adding 8? We're going to subtract 8 from both sides. So we get x equals what? Negative 11? Nice. All right, now that we've kind of done a couple, if you need to kind of try a couple more on your own, feel free. All right, ooh, number 3 is a little tricky. We have negative 5x equals 35. Now, are we going to add 5 or are we going to divide by negative 5? This is a little bit different. We have negative 5x or negative 5 plus x. These are different here. This one's actually, when there's nothing between them, it's going to be smushed together. It's multiplication. So we're actually going to do the opposite of multiplying by negative 5, which is what? We're going to divide by negative 5. So we get x equals, what's 35 divided by negative 5 going to be? It's going to be negative 7. All right, how about number 4? We got x over 6 equals 4. How do we undo dividing by 6? We're going to multiply by 6. So we get x equals 4 times 6 is 24. All right, very cool. Cool. How about, okay, now we're doing multiple steps here, okay? So the trick with this is I would always distribute and combine like terms, and then I would kind of work backwards, right? So we got PEMDAS. I would work your way up, right? I would do addition subtraction first, then go kind of this way. That's probably the best approach is what I would say, okay? So we got negative 3x plus 5 equals 20. So is there any addition or subtraction here to take care of? There is. How do we get rid of that plus 5? We're going to do minus 5 to get that 3x by itself here. So we have negative 3x. What's 20 minus 5 going to be? 15. And what's negative 3x divided by, now we have to get the x by itself. How do we do that? Well, we're the opposite of multiply by negative 3 is to divide by negative 3 on both sides. So we'll do that. Oops. It's not cooperating. Divide by negative 3. So we get x equals 15 divided by negative 3 is going to be negative 5. All right, how about number 6? Anything to distribute here? Yep, we're going to do 5 times x, which is 5x. And 5 times negative 2 is negative 10 equals negative 40. All right, if you want to go ahead and solve it from here, if you didn't get to this part, go ahead. Also, I should point out there's lots of ways to approach this. You could have actually divided both sides by 5. You could actually add 1,000,000 to both sides. There's like, as long as you do it to both sides, there's no limit to what you can do as long as you do it consistently. And maybe different ways that you approach this. I'm just showing you what I think is the most efficient way. So, okay. Now, any addition or subtraction to take care of here? Yeah, I can get rid of this minus 10. How do I get rid of minus 10? What's the opposite? Plus 10. So now we got 5x equals, what's negative 40 plus 10? It's going to be negative 30. How do we undo multiplying by 5? Divide by 5. And we get x equals, what's negative 30 divided by 5 going to be? That's going to be negative 6. All right, make sure you give yourself a rating here if you didn't already. See what you're feeling. It's a pretty important skill for algebra. All right, graphing points. So we have a coordinate plane down here. So you're graphing the points. Why don't you guys go ahead and pause the video, give yourself a rating here, and see if you can graph these points and see how you do. All right, so we have A is 2, negative 6. So we're graphing. So we have x. So we remember here, we have x, y, right? Not y, x. X is going to be left and right, and y is going to be up and down, okay? And so the first number is going to be, you do x first, and then you do y, okay? So if we have 2, if x is positive, we're going to go right. If x is negative, we're going to go left. If y is positive, we're going to go up. And if y is negative, we're going to go down, okay? So let's go ahead and try this here. So we have A, 2, negative 6. Well, A is 2 is, x is positive, we're going to go right 2. And then we have y is negative 6, we're going to go down 6. So right 2, down 6. 2, 3, 4. That's going to be point A. All right. Why don't you guys try a couple more if you're not sure. Now we've kind of done one, but otherwise we'll keep going. All right, 0, negative 2. So I have a question for you. If it's 0, what does it mean to do with that that thing? It means don't move, right? So if it's B is 0, negative 2, we're going to stay on the y-axis. We always start at the origin too, by the way, okay? We're going to stay there. We're going to go down 2. Y is down 2. I see people goof this up a lot. That's why I put it down here to kind of make sure we knew the difference, okay? So if the first number is 0, you're going to stay on the y-axis, right? You're not going to move left or right if it's 0. And if the second one is 0, you're not going to go up or down, okay? So for this one, we had C is negative 2, 0. So what are we going to do first? Well, first we go left or right. So we're going to go left 2, and we're going to stay. We're not going to go on the up or down because there's no value for the y there, okay? How about D? We have negative 3, 4. So D is left 3. So we go left 3. We go up 4. 1, 2, 3, 4. And there's D. All right, and there's our graph. If you want to get more practice here, it says, for example, for 5, you can graph at least 2 more random points and label their coordinates. So, for example, if I just pick a random point here, let's try this. So I pick the point there, I can go 1, 2, 3, 4, 5 to the right, and 1, 2, 3, 4, 5, 6 up. So if we have, call it point E. If for E, we went right 5 and up 6, what would that be? Well, right 5, positive X is going to be 5, and we went up 6, which is positive Y, is going to be 6. Okay, make sure you guys get some more practice here if you would like. All right, how about slope? Why don't you guys go ahead and try to calculate the slope using rise over run. See how you do with this. Give it a try. Okay, so rise over run. Okay, so I like to start with the left-hand point here for this. So left-hand point's right here, and we're going to go up or down to get level with the other point first, okay? So let's see here. So to get to the right-hand point, we're going to go up or down. We're going to go up how many? So we went up 3. So if we go up 3, is that positive 3 or a negative 3? It's going to be positive 3. And we go to the right, and how far to the right we go? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. Up 3, right 5. So what's our rise over run going to be for this one? It's going to be 3 over 5. Okay. You can also, if you wanted to, you can start at the right-hand point. You just got to be careful what you do here, okay? So we start here, and we go to the other point. We're going to go down 3, so that'd be negative 3. When we go left 5, that's going to be negative 5. So it's going to be negative 3 over negative 5, which still is positive 3 over positive 5, which I think is a little bit better to go left to right. It makes things easier, okay? Now that we went through, I want you guys to try number 2, see how you do. Okay, number 2. So starting at the left-hand point here, we got this one up here. So we're going to go up or down. We go down to get level here. Down 3 is negative 3. Right 3 is positive 3. So we have negative 3 over 3. Is our rise over run, which is our slope. And what does that equal when we reduce that? It's negative 1. All right, very cool. What do you remember about the slope formula? Do you guys remember the slope formula? See if you can write down what the slope formula is equal to. It's m equals what? So slope formula is going to be m equals y2 minus y1 over x2 minus x1. Okay? And these are the points over here. Oh, yeah. So you can label your points however you want. Well, kind of, I mean, not exactly however you want, but pretty freely. So let's go ahead and do one here together. Unless you want, let's try one on your own if you want first, and then we'll go through it, okay? So we got to label our points. Just got to make sure everyone has an x and a y, right? Every point needs an x and a y. And you can call it like this is 1, 1, this is 2, 2, or else you can kind of flip them around. You just got to be careful that each point gets an x and a y, and they both are 1, 1, 2, 2, okay? So let's go ahead and do this here. So we have m equals, what's y2? It's 13, minus y1 is 7, over x2, which is 2, minus 3. Why don't you guys go ahead and see if you can simplify this here? So we're going to get m equals, 13 minus 7 is 6. 2 minus 3 is negative 1. That's going to equal negative 6 is our slope. Okay? All right, now we went through. I want you guys to try 4 and 5 if you need more practice here. All right, number 4, we got x1, y1, x2, y2. So we're going to do m equals. So we have y2 minus y1 is going to be, so it's going to be 7 minus negative 3. Be careful, it's minus, always minus negative 3. Or 5 minus 5. Okay? So now if we go ahead and simplify this here, how do we subtract a negative? That's chop, chop. So we get m equals, what's 7 plus 3? 10 over 5 minus 5 is going to be 0. Now, is this going to be 0 or undefined? Okay, so it's going to be undefined when we divide by a, we can't divide by what number, I guess? Can't divide by 0. So 0 over 10 is going to be undefined. Okay, because you can't divide by 0. But if you had like 0 over 3, that would equal 0. Because 0 divided by anything is going to be itself. But the answer for this one's going to be undefined. Because you can't divide by 0. Okay, that's the problem down here. All right, number 5, same thing. M equals y2 is negative 1 minus negative 1 over 6 minus 2. So if we do minus negative 1, we're going to do chop, chop. Negative 1 plus 1 is going to be positive 1. Actually, 0, my bad. 0 over 6 minus 2 is 4. And if we do 0 divided by 4, we're going to get 0. Okay? Very cool. All right, last couple things here. Make sure you guys give yourself a rating for slope. We're going to go ahead and simplify some square roots. See if you guys can solve these. Go ahead. All right, so number 1 is not too bad. This is a perfect square, which means when you take the square root, it's a nice number. What's the square root of 25 going to be? It's going to be equal to 5. 5 times itself. And what is the square root? The square root's going to be like what number times itself equals that number, right? So 5 times 5 is going to equal 25, okay? How about number 2? Ooh, this one's not a perfect square. So we got to find a perfect square that goes into it, right? So something that multiplies to 45 is going to be square root of 9. So 9 times 5 is 45. The reason why that's nice is because 9 is a perfect square. So what we can do is we want to, kind of like when you're factoring or you're fixing fractions, is you want to pull out numbers that go into both. And so in this case, with radicals, you're trying to like break this down into, I guess, numbers that multiply to the number under the radical, which is 45, where one of them is the perfect square, because what's the square root of 9 going to be? It's going to be 3, so we get 3 square root of 5. So that's kind of nice. Okay, why don't you guys try number 3, see if we can figure out what goes in there. Go ahead. All right, so for this one, is a negative a problem if it's outside the radical? It is fine if it's outside the radical. It's just when it's inside the radical that's kind of an issue here. So, so for 50, what's this perfect square that goes into 50? Well, it's going to be 25, and 25 times what is 50? It's 2. So what's the square root of 25 going to be? It's going to be 5, so we got negative 5 square root of 2. Nice. All right, how about number 4? This one's got a problem. What's the problem with it? We have a negative under the radical, so this one's going to be no real solution. No real solution is going to be our answer here. And there we go. All right, and I think it says if there's any topics you want to cover from previous classes, make sure you let Mr. Posky know here, okay? All right, that's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.